In this video, we're going to look at turning products of sine and cos into sums of sine and cos. Now, in these examples, the thing that's of note is that the argument or the angle of the trig functions are actually different. So for example, as I've written here, we have px and qx, where p and q are not the same number. Okay, so that's what makes these interesting. So to do these kinds of integrals, we first have to look at some rules here, some trig relationships. Now, I wouldn't recommend memorizing these to start off with. You might end up memorizing them in the end, but I would definitely recommend learning how to derive these, because I think that that's just giving you a better understanding. So we're going to prove the first result here. We're going to prove this one. The others are very similar, and I'll leave those for you to do in your own time. So to prove the first result, and actually to prove all of these results, what we have to do is we have to look at the expansions of sine a minus b, a plus b, cos a minus b, and a plus b. But for the first one, we only need to look at sine of a minus b and a plus b. Now, these expansions are things that we should know from the Extension 1 course. It's part of the trig that you learn in Extension 1. So sine of a minus b, that's going to be sine a cos b. Let's leave this for a moment, and then the next bit is going to be cos a sine b. It's the same for the second one, sine of a plus b. It's going to be sine a cos b and cos a sine b. The only difference is whether it's a plus or a minus between them. And the way that I remembered it was that for sine, it's always the same sign. So sine of a minus b means we have a negative. Sine of a plus b means we have a plus here, a positive. Okay, so these are our two results that we're going to be looking at, 1 and 2. Now, we want to find a result for sine a cos b. And we can see that we have sine a cos b here and sine a cos b there. So let's add results 1 and 2. So 1 plus 2 is going to give us sine of a minus b plus sine of a plus b. Now we're going to have 2 times sine a cos b. And then if we have a look at the other results, so if we have a look at these two here, well, these are the same, they just have a different sign. One's a negative, one's a positive. So when you add them together, they're going to cancel each other out. So if I now just divide by 2, and I'm just going to rewrite it sort of back to front, so we have sine a cos b. So I've divided by 2, and I get my result. Sine of a minus b plus sine of a plus b. Okay, and there you have it. That's how you can rewrite this product as a sum. And this is what we need to use to solve integrals of the form which we're going to see in the next example. So here's the example. It's the integral of sine 3x times sine of x. So you'll note that the angles of our sines, the arguments, are different. Okay, so that means that we need to appeal to this taking products to sums idea that we just looked at before. So the rule for sine a times sine b, which we had above, which we didn't prove but we had written above, I've just written it down here again. And this is the rule that we're going to use. So really there's nothing to this other than an application of the rule. So in this case, it's going to be a half times cos of a minus b, which will be 3x minus x, minus cos of a plus b, which will be 3x plus x, dx. Let's take the half out the front. This is the integral of cos 2x minus cos 4x. And then, let's fix that up a little bit, cos 4x. And then these integrals are fairly standard. These are just 2 integrals, advanced integrals. So this would be a half times, the integral of cos 2x is sine 2x divided by 2. The integral of cos 4x is sine 4x divided by 4. and we have a plus c.